Here in this section, we have integration by parts. So the first formula that we have is integration by parts, integral ux times v prime of x dx. That is equal to ux times vx minus integral vx times u prime x times dx. The second one that we have here is integration by parts, and it is differential equation. So integral u dv equal to u times v minus integral v times du. And the third one that we have integration by parts for definite integrals. So integral from a to b ux v prime x dx equal to ux vx from a to b minus integral a to b vx times u prime x times dx. So these are three formulas that we have for this section. Example 1, evaluate integral from 1/2 to positive 3. It is 4x times natural log, so it is ln of 2x times dx. So what we have here on this part, u is equal to ln 2x, so this part is u, and dv is 4x times dx. Then based on what we have here, du is equal to 1/x times dx. So I got this part. So du is equal to, here we have ln of 2x. So that is equal to ln2 plus ln x. So where du is equal to this part, derivative of that part is 0, and derivative of this part is 1/x. So 1/x times dx is what I have here on this part. And v is 2 times x squared. So 2x squared, if we try to find derivative of this one, that will be 2 times 2. So it's 4x. It is what we have here on this part. Apply integration by parts. So we have integral 1/2 to 3 4x ln 2x times dx. This is equal to, we should multiply u times a v. So u is ln 2x and v is 2x squared. So we have 2x squared ln 2x from 1/2 to 3 minus integral vx times u prime x. Vx is 2x squared, and u prime or du is equal to 1/x times dx. Then we can simplify. So 2x squared divided by x, we're gonna have 2x. So here I simplify this part, and we're gonna have 2x times dx. So rewriting this part, but I simplified this to 2x. The final integral of what we have here, it is x squared. So adding to the power that we have here, we have 1 plus 1, so that is 2. Divide by same number, so 2 divided by 2 is 1 times x squared. This is what we have here on this part. And now use, our a is 1/2 and b is 3. So use a 3 instead for x. We have 2 times 3 squared times ln 2 times 3 minus, now using 1/2, 2 times 1/2 squared times ln 2 times 1/2. Now for this part, using 3 first instead of x. So we have 3 squared minus, using 1/2, so 1/2 squared. Now we have to simplify. So we have 3 squared. 3 squared is 9. 9 times 2, this part is 18 times ln 2 times 3 is 6 minus 2 times 1 over 2 squared. 1 over 2 squared is 1 over 4. So 1 over 4 times 2, that is 1 over 2. Multiply by ln 2 divided by 2. So 2 divided by 2 is 1. We're going to have ln 1 minus, so use distributive property, negative times 9, negative times negative 1 over 4. So we're going to have negative 9 plus 1 over 4. Now finding final answer, we have 18 ln 6 minus 1 over 2 times ln 1, this part is 0. So 1 over 2 times 0, this part is 0. Minus 9 plus 1 over 4. So we have same denominator for this part. So LCD is 4. So 4 times negative 9 is negative 36 plus 1, we're going to have negative 35. So negative 35 over 4. Final answer is 18 times ln 6 minus 35 divided by 4. Evaluate the integral using integration by parts. Integral x times e power is 11x times dx. So we're going to use integral u times dv equal to u times v minus integral v times du. So in this case, what we have for integral u dv, that is integral x e to the 11 times x times dx. So based on what we have here, we want to find u and dv. Let u equal to x, so what we have here, that part is our u, then du is equal to the derivative of this part with respect to x, that is 1 times dx. If so what we have here is e power is 11x times dx. I'm going to use that one as dv. So dv is equal to e power 11x times dx. Now finding v is equal to integral e power 11x times dx. So instead of what I have here on this part, I'm going to use 1 over 11 times integral 11 e to the power 11x times dx. So I multiply by 11 and divided by 11. So here we have 11 over 11, but I used 1 over 11 on outside of integral. And then that is equal to 1 over 11 integral of 11 times e power 11x times dx is equal to what I have here, e to the power 11x. So if you want to check your answer, integral of what we have here for exponential function. Here power is 11x, so derivative of that part is 11 times e to its power, and we have this part, it's 1 over 11. So this is what exactly we have here on this part. Another example, for example, if you're trying to find, for example, we have e to the x power. Derivative of this, based on what we have for power, here we have x, so derivative of x is 1 times what is given on this part, so times e to the x power, and then times dx. Next step, find u times v. So our u is x and v is 1 over 11 times e power 11x. So this is what we have, 1 over 11 times x times e power 11x. Next step, find v times du, because we're trying to use this formula to find our answer. So v times du, our du is 1 times dx, and v is what we have here. So this is equal to 1 over 11 e power 11x times dx. Next step, substitute the expressions in the formula and integrate. So I'm going to use this formula, integral u times dv equal to uv minus integral v times du. Now what we had for integral u times dv was integral x times e power 11x times dx. That was what was given here on this part. Then use u times v and v times du. So u times v was 1 over 11 times x times e power 11x times dx minus integral v times du was 1 over 11 times e power 11x times dx. Rewriting this part, and what we have for this one, I'm going to use 1 over 11 times 1 over 11, then integral 11 times e power 11x times dx. So this way, if you try to find integral of this part, you're going to have e power 11x. Again, derivative of this part is 11e power 11x, which is what we have exactly here on this part. So 11 times e to the power 11x times dx. It is same as what we have here. So integral of that part is e to the power 11x. And multiply by what we have here, 1 over 121. So this is what we did. So if we try to simplify that part, you're going to have 1 over 11e power 11x dx. This is what exactly we had in first step. So I'm going to erase these. So this means our final answer is rewriting what we had here on this part, minus 121 integral of 11e to the power 11x times dx. That is equal to negative 1 over 121 times e power 11x, and then adding constant. So here is our final answer for this part. Evaluate the integral. Integral on top we have natural log 8x divided by x to the 5th power times dx. So here on this part we're going to use this formula, and what we have for u is ln 8x. So finding du, that is equal to derivative of this part, that is 8 times 1 over what we have here after ln. So derivative of 8x is 8 times 1 over 8x. Simplify, the answer for this part is 1 over x, and dv is 1 over, so what we have here on this part is 1 over x to the 5th power times dx. Instead of writing 1 over x to the 5th power, I'm going to move this to numerator and changing our power from positive to negative. So we have this in numerator, that is x power negative 5 times dx. Now finding v, so add 1, negative 5 plus 1 is negative 4, using same number in denominator. So v is x power negative 4 divided by negative 4. Now, so with the what we have for the final part, I don't want to use negative power, so move this to denominator. So we're going to have negative 1 over 4 times x to the 4th power, and this is positive power. So now our integral is equal to u times v. So we have ln 8x times our v is negative 1 over 4x power 4 minus integral v times du. So our v is 1 over 4x to the 4th power, and here we have negative multiplied by du is 1 over x. So here we have 1 over x times negative 1 over 4x to the 4th power times dx. So I simplify this, so I multiply this part. So what we have here is negative ln 8x divided by 4x to the 4th power plus, I move this outside of integrals, so we have 1 over 4. Here we have negative, here we have negative, so that is positive. And then we have this x, this one is x to the 4th power, so we have 1 over x times 1 over x to the 4th power, that is equal to 1 over x to the 5th power, so we have to add powers 1 plus 4, that is 5. Now finding the derivative of this part, it's exactly the same as what we did here on this part, so moving this power to numerator, now having negative 5 as a power, so it is exactly the same. We're going to have this integral, so integrate that part, that is equal to negative 1 over 4x to the 4th power. And then simplify, so multiply these two, we're going to have 1/4 times negative 1/4, it's negative 1 over 16. The denominator we have 16 times x to the 4th power. And rewriting this part, so our final answer is negative ln 8x divided by 4x to the 4th power minus 1 divided by 16x to the 4th power plus constant, so plus c. So this is final answer for example 3. Evaluate integral x power 13 times square root of x to the 7th power plus 3 times dx. Let u equal to x to the 7th power and dv equal to x to the 6th power times square root of x to the 7th power plus 3 times dx. So what I did on this part, instead of x power 13, I used x power 6 times x power 7. So 6 plus 7, that is equal to 13. Now based on that, du is equal to 7 times x to the 6th power times dx, and v is equal to 1 over 7 times 1 over 3 over 2. So 3 over 2, how I got that one? Here, because of having square root, that part is x to the 7th power plus 3, power is 1 over 2. So finding v, we have to add 1. We're going to have 1 over 2 plus 1, so power will be 3 over 2. Use that same power in denominator, so 1 over 3 over 2, and that will be same as writing 2 over 3. So v is equal to 1 over 7 times 2 over 3 times x to the 7th power plus 3, and power is 3 over 2. Now simplify, so multiply what we have here, so 1 times 2 and 7 times 3. So we have 2 divided by 21 times x to the 7th power plus 3, and power is 3 over 2. Now finding our integral, this is equal to u times v. U is x to the 7th power, and v is what we had here on this part. So multiply these two, and then minus integral v, which is again this part, times du. So I simplified this part, but what we had was this one here on top. So we had v is 7x to the 6th power times u is 2 divided by 21 times x to the 7th power plus 3 power 3 over 2 times dx. So 7 divided by 21, simplify that part, we're going to have 2/3 times x to the 6th power times x to the 7th power plus 3, power is 3 over 2 times dx. rewriting this part, now integrate what we have here on this part. So that is negative 2/3 times power 3/2 plus 1. We're going to have 5/2. So use that power here and then multiply by 1/5/2. So it's this one. Multiply by 1/7. And plus constant is c. Now simplify, so instead of writing this, I have 1/5/2, so I have 2/5. And then multiply all these numbers that we have here in numerator and all that we have here in denominator. So we're going to have negative 4/105 times x to the 7th power plus 3, power is 5/2. So this is our final answer. So final answer for our integral is 2/21 times x to the 7th power times x to the 7th power plus 3, power is 3/2 minus 4 divided by 105 times x to the 7th power plus 3, power is 5/2 plus constant. Evaluate the integral sine 9x times cosine 5x times dx. So I'm going to use a u equal to sine 9x and dv equal to cosine 5x times dx. So based on this, finding the u that is equal to 9 times cosine 9x dx, and v is 1/5 sine 5x. So here derivative of sine is cosine, and to recall, derivative of cosine is negative sine. Now using this formula to find the answer for integral sine 9x cosine 5x times dx, that is equal to u times v. So we have 1/5 times sine 9x times sine 5x minus integral v times du. So I'm writing 9/5 here outside of integral. We have 9/5 times integral sine 5x cosine 9x dx. Rewriting this part, and again we have to use this formula to integrate this term. So I used u equal to cosine 9x, dv as sine 5x dx. Based on that, du is equal to negative 9 sine 9x dx. So what I got here on this part, I use this 9, which is coefficient of x. So 9 times derivative of cosine is negative sine. So negative sine, and rewrite what we have after cosine. And then multiply by dx. So v is equal to, use that number, which is 5. So 1/5, use reciprocal of that, 1/5 times, when we have sine, we're going to have negative. So negative, and then multiply by cosine and rewrite what we have after sine. So we're going to have negative 1/5 times cosine 5x. So instead of this part, now we have u times v. So it is cosine 9x times negative 1/5 cosine 5x, which is what I have here on this part. Then minus integral v times du. So v is negative 1/5 cosine 5x, and du is negative 9 sine 9x times dx. So I use negative 9/5 here outside of integral. And then next step, used distributive property. So I multiply by first and second term. So we have negative 9 times negative 1, we have positive 9, divided by 5 times 5, so it is 25. And then here we have negative 9 times negative 9 is positive 81, denominator 5 times 5 is 25. And next step, so we have this one here on right side. We want to find the answer for integral. As you can see, this is what we have here on left. So that is exactly the same. I can subtract this from both sides. So subtracting 81 over 25, integral sine 9x cosine 5x dx from both sides. So here we're going to have negative 81 over 25 plus 1, that is negative 56 over 25. Then multiply by what we have for integral, equal to rewriting this part plus what we had here. So I just subtracted, meaning that here we're going to have 0. So that part is 0. And final step. So we're trying to find the answer for integral sine 9x cosine 5x dx. But here we have this as negative 56 over 25. So we have to multiply by negative 25 over 56 to be able to cancel this part. We multiply both sides by negative 25 over 56. This one multiplied by negative 25 over 56. We're going to have negative 5 over 56 and multiply this one by same number. So we're going to have negative 9 over 56. And rewrite what we had on that part. Same thing for this one. So the final answer is negative 5 over 56 times sine 9x sine 5x minus 9 over 56 times cosine 9x cosine 5x plus constant. So that is C. So this is our final answer.